Now let us have by elimination. Okay, for by elimination, let me use this again. So 1 is equal to a plus b. 3 is equal to 4a plus 2b. Again, you have to decide which one do you want to eliminate. So if you want to eliminate b, that means we are solving for a. Okay, let's do that. Let's eliminate b. So the b here should be negative 2b, so that it will be eliminated. So let's multiply this by negative 2. So we now have negative 2 equals negative 2a minus 2b. 3 is equal to 4a plus 2b. So negative 2b plus 2b, 0. Negative 2 plus 3, 1. Negative 2a plus 4a, that's 2a. Okay, there. Divide both sides by 2. Then this will give us a equals 1/2, which is the same as this one by doing the substitution. Okay, so we already have the a. Let us now solve for the b by eliminating a. So again, actually, you may perform the elimination for the first variable, and to solve for the b, you may opt to do the elimination or substitute already the a here to get the b. Did you get my did you get what I mean? So again, for the elimination, once you already got the first variable, to solve for the other variable, you may opt to, or you may choose to do the elimination again, or just do the substitution already by substituting a here with 1/2 to get the b. But since I want you to I want to show to you a very comprehensive solution, so let me do elimination. Again, it's your choice. Anyway, that's by elimination. You may do the by substitution for the next one. So for this case, let me do the elimination again. So 1 is equal to a plus b. 3 is equal to 4a plus 2b. So for the first one, we eliminated b to solve for a. So for this one, we're going to eliminate a to solve for the b. So again, to eliminate here, to eliminate a here, that means the a here should be negative 4a. So multiply this by negative 4. Now again, try to recall some of your learnings from high school that we should not always be nailed to this equation to be transformed so that there is something to be eliminated. You may also try to explore on this equation also. But for me, by inspection, it's easier to use to utilize the first equation because it's just a and b, and they have constants of 1 and 1 there. Okay, I hope you're getting my point. So for this one, we have negative 4 is equal to negative 4a minus 4b. Then we write 3 is equal to 4a plus 2b. So obviously, a eliminated. So negative 4 plus 3 is negative 1 equals negative 4 plus 2b. That will give you negative 2b. Then divide both sides by negative 2. There it goes. b is 1/2. Just like what we got from the substitution. Okay, so let us go back. Put this aside. So, there. Where's the table of values? Table of values, where are you? There you go. So let's go back to the problem. So this is the problem. you have the figure 1, the number of cans for figure 1, there's only one can, and so on and so forth. And we have constructed a table of values, and our dilemma now is if there are, for the 10th figure, how many cans will there be? So we need to construct or find the model for this one so that it would be easy for us to solve the number of cans given this f value. So we have already the inspection. So if the second differences here in the dependent variable are similar, then we are referring to quadratic function. And again, if it's a quadratic function, it should follow this function, quadratic. And for our problem, our y, the dependent, is the c of f, and our x, the independent, is the f. That means the number of figure, or the order of the figure, I mean. Okay, the order of the figure, because we're using first, second, third, fourth, and so on and so forth. And then, being strategic to my solutions, so I will be utilizing the 0, 0, because once I'll have that, I can immediately get the value for c, and I will have no problems for the other solutions. Okay, so you have it there. I use the 1, 1, I use the 2, 3, then you have this equation. So by substitution, we got a as 1/2, b as 1/2. And then another method, that's by elimination, using the same equations, of course. The y equals a plus b 3 is equal to 4a plus 2b. Okay, so to solve for a, eliminate b, then we got also 1/2. And then for the next one, to solve for b, eliminate a, we also got 1/2, same as the substitution method. Okay, so let's continue. So let's go back here, there. So let me write the a here, which is 1/2. Let me write the b, which is 1/2. The values that we have found using substitution and elimination. Therefore, we can now have the model for that. That's c of f from here. We can now substitute the values that we got to a, b, and c here. So a is 1/2 f squared plus b, which is 1/2 also, f then plus 0. Finally, the model for it would be 1/2 f squared plus 1/2 f. There. Okay, so let's go back now to our table of values so we can already answer this one. So for the figure 10, so that means if your f is equal to 10, so how many cans will there be? So using now the model, it would be easier for us to solve the problem. So c, f is 10, is equal to 1/2 10 squared plus 1/2 is 10. Again, if you think I am too fast for this one, you may watch again the video. Okay, so that's 10 squared. So we have to do this first before multiplying it to 1/2. So 10 squared is 100 times 1/2, and that will give us 50. Plus, of course, the 1/2 of 10 is 5. Therefore, there will be 55 cans for the 10th figure. Are you getting it now? So, you ready for the shortcuts? I know you are. Okay, let's do that now. So let me go back to the first problem, which is about the linear function. So this is the table of values. There, table of values for the linear function. This, remember the jeepney ride problem. So let me rewrite this. So p and a of p. So you have 0, 1, 2, 3, 0, 7, 14, 21, and so on and so forth, and so on and so forth. So by inspection, 3 minus 2 is 1, 2 minus 1, 1, 1 minus 0, 1. So we can now proceed here, since the first differences of the independent variable are similar. So 21 minus 14, that's 7. 14 minus 7, that's 7. 7 minus 0, that's 7. So if you notice, the 7 here is the A. Therefore, the shortcut is this. Your A is actually your first difference. So again, this is for a linear function. Difference. So this is for the linear function. And then your B would be the value of your Y if your X is 0. Now, since our X here is 0 and our Y is 0, so that means that is your B, which is 0. Get it? Interesting, right? Excuse me. Now, let's have the shortcut for the quadratic function. Going back to this table of values for quadratic. Oh, I'm having colds. Sorry for that. Okay. So let me rewrite the table of values. So you have there 0, 1, 2, 3, which means 0 figure, the first figure, the second figure, the third figure, and so on and so forth. And then for the 0 figure, of course, you'll be needing 0 can. For the first figure, you only have 1 can, 3 cans here, 6 cans there, and so on and so forth. So again, by inspection, 3 minus 2, 1, 2 minus 1, 1, 1 minus 0 is 1. So we can now proceed to the differences of the dependent variable. 6 minus 3 is 3, 3 minus 1 is 2, 1 minus 0 is 1. So let's proceed since the first differences are not the same, therefore this is not a linear function. So let's see if this is a quadratic by going to the second differences. 3 minus 3 is 1, 2 minus 1 is 1. There you go. Okay, therefore this is a quadratic function. Okay, so here's a shortcut. Now the shortcut is this. Therefore, the A here is actually your second difference divide by 2. So we have a constant divisor of 2. So whatever your second difference is, divide by 2. What is the second difference here? 1. Divide by 2, 1/2. So did we get A as 1/2 a while back? Yes, we did. Okay, and then let me jump to the C. C is your Y if your X is 0. So the X here is the F. So if X is 0, your Y is 0, which is your C. And that's what we got also. C is equal to 0. Now for B, in this case, you need to solve. So how? Get any point. So you will be needing any point from the table of values. And then the next one is use now the values of A and C. So how is that? Okay, let's try this. So as an example, I'll be using the 1, 1. Okay, 1, 1. So going back to this equation, our C of F is, so this is my F and this is my C of F. Okay, so from here, so this one, C of F is 1 equals A, we get it as 1/2. So that it says here use the values of A and Z. So we already have the A's, which is 1/2, C which is 0. So that's 1/2. Then your F is 1. plus b, your f is 1, plus c, which is 0. Okay, so if you will continue to solve this one, so that's 1 half times 1, transpose, so that will give you 1 minus 1 half. Of course, it will give you 1 half. Equals b times 1, so since that's 0, 0, so b. Diba? There you go. My first Tagalog. O, diba? Okay, so to further discuss about the shortcuts, which I know you are more interested than the two other methods, which are elimination and substitution. So most interested, I should say. So let us have table of values as example.